We experience time as something obvious. The past is gone, the present is happening, and the future has not arrived yet. This feels so natural that we rarely question it. Time moves forward. Events happen once. What is done stays behind us forever. Physics does not experience time the way we do, and the deeper it looks, the less confident it becomes that the past is truly gone. For most of human history, time was treated as absolute, a universal clock ticking forward, the same for everyone, everywhere. This idea worked well. It matched intuition and daily life. Then, physics interfered. Einstein showed that time is not universal. It stretches, it slows down, and it depends on motion and gravity. Two observers can disagree on how much time has passed, and both can be correct. Time, it turned out, was already more fragile than we thought. But relativity only bent time. Quantum physics questions whether it exists in the way we assume at all. In classical thinking, the past is fixed. Every event leaves behind a definite history. Once something happens, it becomes part of an unchangeable timeline. Quantum physics does not share this certainty. At the quantum level, events do not always have a single, well-defined history. In some experiments, particles behave as if their past is undecided, until measured, not altered, not rewritten, but undecided. One of the most unsettling ideas in modern physics is that quantum systems do not always have a definite past. Before measurement, a particle exists in superposition, multiple states, multiple possibilities coexisting. This is well established. What is less intuitive is that this uncertainty may extend backward in time. In certain quantum experiments, the outcome of a measurement appears to determine how a particle behaved earlier. The system acts as if its history depends on how it is observed later. This does not mean the past has changed. That would imply paradoxes and contradictions. Instead, it suggests something stranger. The past may not be fully real until it is anchored by interaction. This idea feels impossible because it clashes with causality. We assume causes precede effects. We assume yesterday determines today, not the other way around. Quantum physics does not reject causality outright, but it weakens its certainty. At fundamental scales, the universe seems less concerned with chronological order than with consistency. To understand why this matters, we need to rethink what time actually is. We treat time as a flow, a moving present sliding from past to future. Physics does not describe time as something that flows. In equations, time is a parameter, a dimension. It does not move or progress. It simply exists. This creates a problem. If time does not flow at the fundamental level, why does it feel like it does? Some physicists suggest that the flow of time is not a feature of reality itself, but a feature of perception. We remember the past, and we do not remember the future. This asymmetry creates the sensation of movement. But memory alone cannot explain why the past feels fixed while the future feels open. Quantum physics complicates this further. At the quantum level, the future is not fully determined. Outcomes exist as probabilities until measurement occurs. This is familiar. But if the future is open and the past is fixed, where does the transition happen? When does possibility become history? Quantum theory does not give a clean answer. In some interpretations, the universe does not select a single timeline. All possible histories exist simultaneously, branching at every quantum event. In this view, the past still exists, not as one definitive story, but as a collection of consistent histories. We experience one of them, not because it is special, but because it is the one we are embedded in. Time, in this picture, is not a line, it is a landscape. Other interpretations go further. They suggest that time itself is not fundamental. There is no universal past, present, or future at the deepest level of reality. Instead, there are relationships between events. What we call the past is simply a stable pattern of correlations that persists. If this is true, then the past does not exist as a place you could return to. It exists as information encoded in the present. This aligns with another strange feature of physics. The fundamental laws of nature do not distinguish between past and future. Most equations work equally well forward or backward in time. The arrow of time, the sense that time moves in one direction, comes from entropy, not from the laws themselves. Disorder increases, information spreads. Systems lose track of their initial conditions. The past feels different because it was more ordered. not because it no longer exists. But order is not existence. A memory is not the event itself. So where is the past, really? In quantum physics, information is never truly destroyed. Even when systems evolve, the underlying information is preserved in complex and inaccessible ways. This raises a disturbing possibility. The past may still exist, not as experience, but as structure. The universe may not erase what happens. It may only bury it. If so, then every moment leaves a permanent imprint, not in time as we imagine it, but in the total state of reality. Nothing truly disappears. It becomes unreachable, entangled, diluted beyond recognition. As we approach 2026, these questions feel less abstract. Physics is no longer just describing what happens in the universe. It is questioning what it means for something to have happened at all. If the past still exists in some form, then time is not a river carrying moments away. It is a vast structure where everything that ever occurred still has a place, even if we can never return to it. This does not mean the past can be changed. It means it may never have been as simple as gone. The most unsettling possibility is not that the past still exists. It is that time itself may be an illusion created by our limited perspective. Reality may not move forward. We do. And what we call the past may simply be the part of reality we can no longer access.